Is it audible now? Audible and
Yes,
visible?
sir. Visible, sir.
Okay. So some student was writing what we were discussing in the last class. So in the last class, I have discussed work, ठीक है, positive work, negative work, zero work, ठीक है. I have discussed energy, power, ठीक है. And then I have discussed, I think last was conservation of linear momentum. ठीक है. So a part of next to the conservation of linear momentum is collision. So this is the last topic of this chapter, work, energy and power, that is collision. Actually collision actually you apply conservation of energy, mechanical energy, as well as conservation of linear momentum. So on the combination of these two you are going to solve the problems related to collision. So what is collision? Collision is an isolated event. ठीक है, you can say this collision, you can write collision is an isolated event, is an isolated event in which very strong force, in which very strong force acts between colliding bodies, in which very strong force acts between colliding bodies. Full stop. This force is so strong, this force is so strong that this force is so strong that at least direction of one of the bodies of the moving body may change. ठीक है ना? That at least direction of one of the colliding particle changes abruptly. ठीक है? It is so strong force that that the direction of at least one colliding particle changes abruptly. ठीक है? And velocity also changes. Velocity also changes. So here, what you observe, you are not going to observe this collision at the time of colliding, but you are going to observe this event much before the collision and much after the collision. So that's why here you write before collision, and here you write after collision. ठीक है ना? After collision. So when they are actually interacting through strong forces at that time, ठीक है ना, uh, we are not going to observe this event because that is a very strong force and it is very difficult to consider the event at that place. But it is very simple if we observe this event, ठीक है, much before the collision and much after the collision. We will be able to find out what was the direction of the incident colliding particle before the collision and what is the direction as well as velocities of the particles after collision. So that's why we observe this collision event much before it and after the collision. In this way we are going to observe this. So this is a isolated event in which, ठीक है ना, and this in which, ठीक है, strong force acted in between these particles, and this force is so strong that you can even ignore the gravitational force and etc. So you are going to neglect that type of force here, gravitational force. The reason is, as compared to this strong force, that will be negligible. That will be negligible. That's why when we are solving questions related to collision, we don't consider this gravitational force. ठीक है? So now come to the collision again. If you look at collision may be classified, or collision may be divided into two parts. ठीक है ना? Collision may be divided into two parts. First is called as elastic collision. First is elastic collision. Elastic collision. And second type of collision is inelastic collision. inelastic collision. What is the meaning of elastic collision? Elastic collision, in case of elastic collision, ठीक है, kinetic energy before the collision and kinetic energy after the collision remains same. Means kinetic energy before collision Ki will be equal to kinetic energy after collision, final kinetic energy. So elastic collisions are those collisions in which kinetic energy of the particles before collision will be equal to the kinetic energy of the particles after collision. So if here, for example, here, these two particles, they are colliding, and after collision, they are having velocities v1 and v2. So basically here, if their masses, you assume this is m1, this is m2, this is m1 and m2, then in this case, 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square will be equal to final kinetic energy, that will be 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. V2 square. So how can you define, if someone asks you what is elastic collision? That is very simple. That kinetic energy of the colliding particle before collision will remain equal to the kinetic energy of the particles after collision. If this condition is satisfied, then you are going to say this is elastic collision. Then you will say this is elastic collision. Okay? So this will be the condition. This will be the equation for the for not conservation, but for this equation Ki equal to Kf. Initial kinetic energy that will be equal to final kinetic energy. Second thing here, I'm saying this is an isolated event. What I'm saying isolated event means no external force is acting. ठीक है, what I am saying isolated event means no external force is acting on these particles, and I am saying that gravitational force, that is negligible, because this strong force is much stronger as compared to gravitational force, and you can neglect that one. So here you are saying, when you are saying isolated event, you are saying no external force is acting. You are saying no external force is acting. Force is acting. ठीक है. So basically, when no external force is acting, then what will be the what will be the consequence of this? I'm writing here. If no external force is acting, okay, you can say this is what? Just I'm saying this is no external force is acting. You are saying F external is 0. F external is 0 means dp of the system by dt. How you represent force? Force is represented as rate of change of linear momentum of the system. So net external force, that will be equal to the rate of change of the momentum, linear momentum of the system. So that will be 0. So what you are saying that linear momentum of the system, this will be constant. This is going to be constant. So linear momentum of the system remains constant in the collision process. Not even in elastic collision, but if you look at inelastic collision also, this equation in which linear momentum of the system remains constant or remain conserved, this will be applicable in every type of collision here. It may be elastic collision, it may be inelastic collision. This will be applicable in both cases. So here my second equation will be m1 u1, this is the momentum of the first particle, plus this will be m2 u2, this will be equal to m1 v1 plus this will be m2 v2. ठीक है. So this is corresponding to the kinetic energy. Kinetic energy before the collision is equal to kinetic energy after collision, and this is corresponding to conservation of linear momentum because no external force is acting on the system. If you solve these two equations, you can find out V1 and V2. This V1 and V2 in terms of U1 and U2 and masses. ठीक है. So how can you solve? Very easily you can solve. You can combine these U1 and V1 together here and here, and by solving these two equations you will find out. I can show you how you can solve it easily. From first equation, I'm using another color. I'm not going to completely solve it, but I'm showing you how to solve. You can write this equation in this way. This equation can be written as, this will be M1, this will be U1 square minus, this will be, here bring this V1 square on this side, V1 square, and on this side this will be M2, this will be V2 square minus this is U2 square. This will be first equation. You can write this equation in this way, that M1, this will be U1 minus V1, and this will be M2, this will be V2 minus U2. ठीक है. You can factorize these terms. ठीक है. When you are going to factorize them, ठीक है, this will be U1 plus V1, U1 minus V1, this will be V2 plus U2, V2 minus U2. So by solving these two equations, this equation, and by dividing this, what equation you are going to get, you will get from here, this will be U1 plus V1, and this will be, here you are going to get V2 plus U2. So you are going to get these two equations. If you solve these two equations and find out V1 and V2, you will have this type of equation. What will be V1? V1 will be M1 minus M2 divided by M1 plus M2. And this will be U1 plus, this will be 2 times M2 divided by M1 plus M2, and this will be U2. This will be V1. Second will be V2. V2 will be 2M1 divided by M1 plus M2, and this will be U1 plus, this will be M2 minus M1 divided by M1 plus M2, and this will be U2. Okay? So you have to remember these equations. With the help of this, very easily you can find out the velocity of the particles after collision, which are undergoing elastic type of collision. If two particles are undergoing one-dimensional elastic collision, then with the help of these equations, you can easily find out this V1 and V2. So when these equations are valid, suppose this is the first particle, M1, it was moving with a velocity U1. It is colliding with another particle that is moving with a velocity U2, mass is M2, and this is before collision. And after collision, both these particles, after collision, they are following the same line. Try to understand, these particles, they are moving along the same line. So this type of collision is called as one-dimensional collision, 1D collision. And here velocity of the first particle changes to V1, and velocity of the second particle, ठीक है, this changes to V2, and this is M2. This was M1, sorry. This is M1. So this is the situation. If you are having this type of 1D elastic collision, what you call it? You call it as one-dimensional elastic collision. Elastic collision. Then you can use this equation to solve the problem. Is it clear to everyone up to this point, beta?
Yes,
Yes,
sir.
sir.
Now, here many cases may be there. If M1, but two important cases are there if M1 is equal to M2. If M1 is equal to M2, try to understand here this will be 0. So what will be the consequence of this if M1 is equal to M2? Then this V1, you can look at this V1. This will become 0. This term if M1 is equal to M2, this will be 1 here. This term will be 1. And this V1 is going to U2. V1 is going to U2. So V1 कितना हो जाएगा? That will be U2. And what will happen to this V2? You can say, what will happen to this V2? This term will be 0 and this will become U1. U1. So if what is the meaning of this? If two particles of the same mass, they are colliding with each other, then their velocities will be interchanged. This V1 will be equal to the velocity of this, and this V2 will be the velocity will be equal to the velocity of the first particle. So their velocities they are going to change. So this is one of the important case. If M1 and M2 they are equal, then their velocities they are going to interchange. They are going to interchange. Now suppose second case, if what is the condition? If M1 is equal to M2, and apart from this there is one more condition that this U2 is 0. Then what will be the consequence of this? So this U2 is 0, these two terms, they will be 0. Okay, this second term, they will be 0. What will be V1 here? What will be V1 here? So try to understand this V1 will become 0. And what will be V2? V2, if you look at this V2, this will be U1. So actually, this is a corollary of this first one. First is saying that if masses are equal, then velocities are going to interchange. In the similar case, this is if masses are equal and suppose this U2 is 0, then automatically corresponding if U2 is 0, then V1 is going to be 0. And if this second particle is moving with U2, then first particle is this V1, it will be equal to U2. So this will become U1. ठीक है ना? This will become U1. So they will be interchanged. If you are saying this is becoming 0, then here this will be 0. And what will be V2? That will be equal to U1. It will become like this. If M1 and M2, they are equal. If M1 and M2 are equal, beta. ठीक है ना? This will be the situation. So this is the corollary of the first case. I have written it as a third case. Third case. This is also very important. And suppose one more case. If what will happen if this second mass M2, ठीक है ना? If you say that M2 is much greater than M1, तब क्या होगा बेटा? If the case is when M2 is much greater than M1 and you are following this condition also that U2 is 0, you are saying second particle is at rest and very heavy. ठीक है? Second particle, this particle is very heavy and at rest. And at rest. Then what will happen? In that case, try to understand this U2 is 0, so these two will be 0. These two are going to be 0. So first thing, what will be this V1? V1, ठीक है? M2 is very large, so M1 can be neglected, so this will be minus U1. Try to understand, this will be minus U1. ठीक है ना? Because M2 is much larger, so you can neglect M1, so this will be minus M2 upon M2. So this will be minus 1 and this will be here. And in this case, this M2 is very large here. So automatically this V2, ठीक है ना? This V2 will be 0. So second particle will remain at rest and first particle that is going to change its direction. So what will happen here, if a very heavy particle is there, and it is at rest, then this particle that is moving with a velocity u1, okay, this m2 is very, very heavy as compared to m1, like a wall. Okay, you can consider the case of a wall. When a ball is colliding with a wall, wall will remain at rest and ball will be reflected back in the reverse direction. So what will happen after collision? It will remain as it is. M2 will remain as it is after collision. But this first particle, this will be M1, and it will have a reverse direction velocity that will be equal to U1. So this is the example of a wall. If you are having a wall like this and a ball is going to hit it with some velocity. So if this ball is hitting this wall with some velocity here, whatever is its velocity, it will be reflected back in the reverse direction and its velocity will be minus v. I'm not writing minus because I have shown this direction by an arrow. So this will be, so it will be reversed back. This is the third case. So these three cases, they are quite important, particularly this second one. So this is one of the very important case and you have to remember it. So this is 1D, one-dimensional elastic collision. This is one-dimensional elastic collision. Is it clear, beta?
Yes, sir.
Now suppose collision is two-dimensional. Second case may be 2D elastic collision. 2D elastic collision. Here in this case, in case of 2D elastic collision, you don't have a formula, but you are going to follow this procedure. Suppose this is one of the particle whose mass is m1 and it is moving towards second particle. Second particle is this is m2. Okay? It undergoes and it is moving, suppose in this direction with the velocity u2, and this is moving with u1. So they are moving. This is the line of motion for these two particles. And after collision, so here after collision, okay, suppose one of the particle is moving in this direction. One of the particle moves in this direction with the velocity v1, this is m1, and another particle m2, and this is moving with a velocity v2. Suppose this is theta, you can say this is phi. This type of situation you may have, because this is elastic collision, so kinetic energy before collision will be equal to kinetic energy after collision. So one of the equation you will have here, that will be 1 by 2. What is the kinetic energy of this? That is 1 by 2 m1 u1 square. Second will be 1 by 2 m2 u2 square. And this will be equal to kinetic energy after collision. Here velocity is in this direction, and you know that kinetic energy is a scalar quantity. So how much it will be? This will be 1 by 2 m1 v1 square, okay, plus 1 by 2 m2 v2 square. So this will be one of the equation you are going to use to solve this problem. Second, you are going to apply conservation of linear momentum in two directions. One direction is this is x cap direction. And here this will be y cap direction. X cap direction, this will be y cap direction. So first apply the conservation of linear momentum in the x direction. So conservation of linear momentum in the x direction, what is the initial momentum, linear momentum in the x direction before collision? That will be, second equation will be m1 u1 in x direction plus m2 u2 in the x direction before collision. After collision, component of this here, this will be m1 v1 cos of theta plus this will be m2 v2, this will be cos of phi, cos phi. This will be second equation you are going to have. Third equation will be conservation of linear momentum in the y cap direction. So if you look at before collision here, if you look at this case before collision, then you will find out that there is no momentum component in the y direction. In the y direction, there is no momentum. So in y direction, momentum is 0 before collision. After collision, component of this is having a momentum m1 v1 and component in this direction will be m1 v1 sine theta, and in the downward direction it is going to have here with minus sign m2 v2, and this will be sine phi. This is equation number 3. ठीक है ना? This is equation number 3. So from these 3 equations you are going to solve this problem. Some of the quantities will be provided to you. They will be numerical. They will have numerical values. Substitute those values here and you can find out whatever they are asking you to calculate. There is no formula here, but this is simple procedure. One equation you are going to get from the fact that kinetic energy before collision will be exactly equal to kinetic energy after collision. And second, 2 other equations you are going to get from conservation of linear momentum in the x direction and in the y direction. ठीक है? By applying these equations, by writing these equations, you can solve this question. So some of the numerical values will be provided to you. Substitute those values. Some value you have to calculate and other values you are going to eliminate. By using elimination method, you will find out the required values. For example, they ask you to calculate V1, V2, then you can calculate here. ठीक है? Other values will be provided to you. ठीक है? Other values they are going to provide to you. Now come to inelastic collision. Is it clear up to this point?
Yes, sir.
Next is inelastic collision where we were here. ठीक है? Second type of collisions are inelastic collision. Inelastic collisions are those collisions where Ki is not equal to Kf. ठीक है? So inelastic collisions are those collisions where initial kinetic energy of the colliding particles, ठीक है, is not equal to the final kinetic energy they are possessing after collision. So if they are equal, these kinetic energies are equal, then this is elastic collision. If they are not equal, that is inelastic collision. So next is inelastic collision. Inelastic collision. Inelastic collision. So in case of inelastic collision, Ki is not equal to Kf. So automatically you cannot use the equation where Ki is equal to Kf. You cannot create that type of equation here. Now, how you are going to solve this type of question? So here again there may be 2 cases and you are going to handle these 2 cases in different ways. So first is perfectly inelastic collision. Perfectly inelastic collision. Elastic collision. And second is semi-elastic collision. And next is semi-elastic collision. Semi-elastic collision. So 2 type of inelastic collisions may be there. ठीक है ना? One type of will be perfectly inelastic collision and second will be semi-elastic collision. So in case of perfectly elastic collision, what is going to happen here? This is one of the particle of mass m1. Its velocity is u1. It is colliding with second particle that is of mass m2. Its velocity is suppose u2, and in this collision they are going to club together. Okay, they are going to club together, and as a single body they are going to meet. They are going to move. Okay, so what is going to happen here? Okay, they will combine these two bodies. They are going to combine together. This is m1 and m2. So their mass will become m1 plus m2, and they are going to move with a velocity v. Okay, so they are going to club here. So you can write here in case of perfectly. You can write here in case of perfectly inelastic collision. In case of perfectly inelastic collision, two bodies are going to club together. Two bodies are going to club together or stick together and move with the same velocity and move with the same velocity. So they are going to club together or stick together, and then both are going to move with the same velocity as a single body. So what will be the mass here? Mass will be m1 plus m2. So here in this 1D problem, 1D perfectly inelastic problem, what you are going to do here? Basically apply conservation of linear momentum. So final momentum m1 plus m2 into v, this will be equal to sorry, this will be m1 u1 plus m2 u2. So what will be the velocity here? Velocity here is m1 u1 plus m2 u2 divided by m1 plus m2. This will be the velocity. So this will be the velocity v of this combined body. This body is moving together as a single body. Now, here one of the most important question they ask you what will be the change in kinetic energy. Okay, here they can ask you what will be the change in kinetic energy in this case. So what will be the change in kinetic energy? In this case delta K कितना होगा? Anyone remember बेटा? How much will be the change in kinetic energy? बोलो बेटा. What will be the change of kinetic energy in case of perfectly inelastic collision? In case of perfectly inelastic collision, can anyone tell me what will be this? बोलिए बेटा. So what was the, okay, one more thing you are going to tell me. I'm writing here first. This will be m1 u1 square plus m2 1 by 2 m2 u2 square minus 1 by 2 m1 plus m2 plus m2, and this will be v square. It is like this. This will be a change in kinetic energy. One more thing here I want to tell you in case of inelastic collision before moving forward. Inelastic collision. I'm saying in case of inelastic collision, Ki is not equal to Kf. Here two cases may be there. ठीक है? Ki, or you can say Kf is less than Ki. ठीक है? Final kinetic energy may be less than initial kinetic energy. So here what is going to happen here? Some energy will be lost, in the form of thermal energy, in the form of thermal energy. Thermal energy. One thing, this may happen. So this is the possibility. Second case here, it is also possible that final kinetic energy is greater than initial kinetic energy. So from where this kinetic energy is coming, this extra kinetic energy. So what is going to happen here? Some of the internal energy will convert into some of the internal energy associated with the system is going to convert into the kinetic energy. So here, some of the internal energy, some internal energy is is converting into kinetic energy. So both these possibilities are there. ठीक है ना? So these two possibilities are there. Now come back to this. Now substitute here. Actually, this type of numericals you are going to face here. ठीक है? So they may ask you, in case of perfectly inelastic collision, they will ask you what will the change in kinetic energy. This is a very common question in collision problems. So here it will be 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square minus 1 by 2. This will be m1 plus m2, and this will be m1 u1 plus m2 u2 square divided by m1 plus m2 whole square. So here this part is going to cancel out, and it will be 1 by 2 will be common. I can take this 1 by 2 common. ठीक है? I can take this part as LCM m1 plus m2 m2, and here you are going to multiply this with this and this. So this will be m1 square u1 square. Second will be m1 m2. This will be u1 square. Second with this will be m1 m2. This will be u2 square. And second will be second will be plus m2 square u2 square. And this will be minus square of this. So this will be m1 square u1 square minus m2 square u2 square plus, and this will be minus 2 times m1 m2 and u1, this will be u2. It will be like this. ठीक है? So if you look at this, this is going to cancel this one. ठीक है? And this is going to cancel out by this. And you can take m1 m2 common. So this will be 1 by 2 m1 m2 divided by m1 plus m2. And what is left here? u1 square plus u2 square minus twice of u1 u2. So this will be u1 minus u2, and this will be whole square. And this will be change in kinetic energy. So this will be the change in kinetic energy in case of perfectly inelastic collision. So if you are observing a perfectly inelastic collision, then in this case, This will be the change in kinetic energy. If they ask you to find out the velocity of the combined body as a result of perfectly inelastic collision, this will be the velocity. You can find it with the help of conservation of linear momentum. And if you want to find out change in kinetic energy, this will be the change in kinetic energy. Okay? So this will be the change in kinetic energy in this case. Now come to semi-elastic collisions. Second type of collision is semi-elastic collision. Next is semi-elastic collision. So in this case, semi-elastic collisions, they are in between elastic collision and perfectly inelastic collision. ठीक है? So three type of collisions are there. ठीक है? Here elastic collisions are there. Then semi-elastic collisions are there. Semi-elastic collision. And next is perfectly inelastic collision. Perfectly inelastic collision. Collision. So basically, you can also classify them in terms of a new quantity that we are going to call it. This is called as E. ठीक है ना? Here you called it as E as coefficient of restitution. ठीक है? You can also classify these three into three different categories with the help of a new coefficient that is called as coefficient of restitution. What is coefficient of restitution? First I write here for elastic collision E is 1. ठीक है? For perfectly inelastic collision this coefficient will be 0. This will be 0. And for semi-elastic, it will have a value greater than 0, less than 1. So on the basis of this coefficient of restitution, one can also decide, okay, this is elastic, this is perfectly inelastic or semi-elastic. So this is called as coefficient of restitution. Coefficient of restitution. What is coefficient of restitution? Actually, when collision, before the collision take place, this is U1, try to understand. This is of mass M1. This is second one. This will be M2. And this is moving with U2. So if you want that collision should occur between them, then they should approach, they should approach to each other. So try to understand their relative separation should decrease. Their relative separation should decrease, beta. If you want this, if you want that collision should occur, then their separation, relative separation, it is going to decrease. Means they are approaching. Means here for collision they are approaching. You can write here for collision they are approaching towards each other. They are approaching towards each other. They are going to approach towards each other, only then collision is going to take place. So what will be the velocity of approach of this M1 towards M2? That will be U1 minus U2. That will be, means you can say this will be the velocity of this M1 with respect to M2. So that will be U1 minus U2. So that is called as velocity of approach here. Here I'm going to write velocity of approach. velocity of approach. And I'm writing it in the mode. So here, what is velocity of approach? You can write it as u1 minus u2. ठीक है. Second, after collision, this is first particle m1, m1. This is moving with velocity v1, and this is second particle. So after collision, try to understand this second particle. So first was approaching towards second one and collided it. And now what will be the reaction? Okay. Now what will the consequence of this collision? Not reaction, consequence of this collision. Now second particle, it will try to move away from the first one. As a result, what will happen? This will second one will move away from the second one. So second second particle is going to move away from the first one as a result of collision. So what will be happen here? Recession will take place. Second particle will try to move away from the second. Means this will be v2, velocity of second particle with respect to first one. This will be. And this is called as velocity of recession. This will be velocity of recession. So this is the way to define this coefficient of restitution. So how you define coefficient of restitution? It is the ratio of velocity of recession to the velocity of the approach. In the form of equation, you can write like this: v2 minus v1. That will be E times u1 minus u2. Remember this in case of inelastic collision. Okay, you don't have the equation corresponding to kinetic energy because kinetic energy is changing. So kinetic energy after collision is different from kinetic energy before collision. So you cannot use that as an equation. But here you can use this equation. So whenever 1D question, one dimensional question related to the semi-elastic collision will be there, they are going to provide you this value of E. Okay, it may be 0.6, 0.7, 0.8, whatever value they are going to use. You are going to use one of this equation. So in case of semi-elastic collisions, one equation will be this V2 minus V1, and that will be E times, this will be U1 minus U2. This will be the first equation. What will be the second equation here? Second equation will be corresponding to conservation of linear momentum. So that will be, you can write any way, you can write m1 v1 final momentum, m2 v2, and this will be m1 u1 plus this will be m2 u2. This is the second equation. Okay, so these are two equations. And now by solving these equations, you can find out v1 and v2. You can find out v1 and v2. So on solving, what you are going to get? On solving, you can find out v1 and v2. v1, that is going to come out to be m1 minus, you try to solve it, m1 minus e times m2 divided by m1 plus m2 u1 plus, this will be 1 plus e, ठीक है, 1 plus e m2 divided by m1 plus m2, and this will be u2. And here v2 this will be 1 plus E, ठीक है, 1 plus E, this will be M1 divided by M1 plus M2, and this will be U1 plus this will be M2 minus E times M1 divided by M1 plus M2, and this will be U2. So by using these two equations, ठीक है ना, I will not suggest that you use these equations. You just write these two equations and solve them, because you will have numbers, so it will be very easy to solve. Here this is algebraic, so that's why you are getting this form. But if you substitute whatever numbers are given here, it will be more easy to solve these two equations. But you can remember these also if you need. So in this way you can solve this type of equation. ठीक है? So three type of collisions may be there. ठीक है? First is first is elastic collision, where initial kinetic energy is equal to the final kinetic energy. Second is inelastic collision, where Ki is not equal to Kf. This inelastic collision may be of two types: perfectly inelastic collision, where two colliding particles, they stick together and move together with the same velocity. And second is semi-elastic collision, ठीक है, that is in between these two extreme situations. Here what you are having, here you are having this, you are going to get this equation. Here you are going to use this equation and this conservation of linear momentum equation to solve the problem. ठीक है, in this way you are going to solve the problem. ठीक है, is it okay beta? Is it clear to everyone?
Yes, sir.
Good. Now suppose you are having one more type of question may be there. Suppose you are having an object of mass 4m. ठीक है, you are having this type of mass whose mass is 4m. Now what happened here, that okay, I will show you like this. Suppose its explosion takes place, external and no external forces there, ठीक है, this is before explosion, this is before explosion. Explosion, and it is at rest. It explodes. So after explosion, sorry. After explosion, what happens? It divides into three parts. So due to explosion, it is going to divide into three parts. So initially this was the case. This was. So what happened here? This, suppose this mass is m, one of the particle. It explodes into three different parts. So one part, this is moving with the velocity u. Second part is here, or I say this is moving with 2u. I'm saying this is moving with a speed 2u in this direction. Second part, that is of mass 2m. Its mass is how much? That is 2m. And it is moving with the velocity u. Okay? So two of its part, they are moving mutually perpendicular in two mutually perpendicular direction. Okay? With a velocity 2u and u respectively. Now you have to find out the direction, okay, na, velocity direction as well as velocity of the third with respect to this first one. इसके respect में with respect to this first, I call it as 1, I call it as 2. You have to find out the velocity, its magnitude and direction with respect to first. So how you are going to solve it? So you are aware that total linear momentum will be 0. What is linear momentum here? This is at rest. So try to understand initial linear momentum is 0. So finally total linear momentum should be 0. So what is this? What is the momentum of this here? I write this will be 2 mu. So I write here 2 mu and this will be how much? So I'm saying its momentum is 2 mu here. What it will be? This is also 2 mu. Okay, so what I'm saying, one is having a linear momentum P1 in this direction 2 mu. Second is also having same linear momentum 2 mu. So what will be the resultant of these two?
सर
Yes, beta, please.
ये राइट हैंड डायरेक्शन में ये जो एम है उसके लिए 2 mu कैसे, वो 2 कैसे हुआ?
Its velocity I have given as 2u.
ओके
Okay,
ओके
this is u. You can also change velocity, it doesn't matter. So what you are going to do, you have to find out the resultant of these two. So this is P1, you can say this is P1, this is P2. Okay, this is P2. So what will the resultant of these two vectors P1 and P2? That will be from here. This will be the resultant. And what will the magnitude of this? Its magnitude will be, because they are mutually perpendicular to each other, so this will be 2 mu square plus 2 mu square. Okay, it's not necessary that they are at the right angle, but you have to find out the resultant. Okay, but you have to find out the resultant. What are the resultant of two vectors? Suppose you are having P1 plus P2, and I want to find out the resultant of these two. So that P vector will be how much magnitude wise? This P will be equal to how much? Can anyone tell me? This will be square root of P1 square plus P2 square plus 2P1 P2 cos theta. And what is cos theta? Cos theta is the angle between these two vectors. Suppose this is P1 and this will be P2. P2 and this will be theta. So it's not necessary that this will be 90 degree. Okay, if it is at angle theta, by using this formula, you can find out the resultant. So what will be the resultant of these two? Resultant of these two will be like this. This will be the resultant, P vector. And even if you want to find out this alpha, what will be this tan alpha? Tan alpha will be, kitna hoga anyone? This angle alpha is with P1, so it will be P2. If you remember this formula, P2 sine alpha from your vector understanding, P2, and this will be P1 plus P2 cos alpha. Do you remember this formula from vector analysis? So this will be the magnitude of two vectors and this will be the direction. This angle alpha, it is providing me the direction of the resultant vector with respect to P1. With respect to P1. So even in case this angle is not 90, you can find out. So it will be how much? This will be 2 root 2 and this will be mu. Mu. And angle. So here resultant will be here. So resultant of these two is going to be at 45 degree here because they are equal. So this is. So what will be the resultant of the third one? तीसरे का momentum कितना होगा? So try to understand the momentum here for the third it will be here. Momentum of third will be here in this direction. This will be P3. This will be P3 beta. P3. And what will be the mass of this particle? Try to understand, this is m, this is 2m, so this will be m because total mass is 4m. So this will be P3. So P3 direction magnitude wise, this will be 2 root 2 mu. What is the mass of this m? I'm saying its velocity is v3. So this will be mv3. This will be 2 root 2 and this will be mu. So m will cancel out and this v3, that will be 2 root 2 into u. This will be your answer. So this will be v3 beta. And its direction will be at, you can say this angle, you can say this is 45. This is 45. So this will be the direction here. So this will be ये कितना होना चाहिए? This should be minus alpha. You can say this angle is 135 degree. In any way you can define. ठीक है? This will be 135. So minus 135 degree. This angle will be minus because this is in clockwise direction. So the result, this P3 is making an angle minus 135 degree. ठीक है ना? With respect to this first particle motion. So in this way, this type of question you can solve. Is this question clear to everyone? This is a very good question.
Yes,
Hello.
sir.
ठीक है बेटा. So in the next class, I will discuss questions related numerical problems of collision and related to work energy. So whatever questions are up to this point, I will try to discuss all those questions by the end of this week. So by the end of this week, I will complete up to collision. ठीक है? Then one chapter will be left, that is rotational dynamics. So this week I will try to take classes so that I can complete all the numericals. Theory part is already completed.
सर
Yes, beta, please.
ये 135 डिग्री कैसा है एक बार बता दीजिए ना.
Beta, this is because this actually this magnitude and this magnitude, they are equal. These are two vector. One vector is this, another vector is this, and they are in perpendicular to each other and their magnitudes are equal. So what will be this angle of this resultant? Their resultant will make 45 degree.
डिग्री.
ठीक है? So look like this. Try to understand. This is 45, so automatically this will be 45. So what will be this angle? 180 minus 45. ठीक है? So
ओके
this will be 135. So here this angle, this will be 145, 135. ठीक है ना? This will be 135.
सर द लास्ट स्लाइड प्लीज.
Oh, last one. So here I am use simple formula. You are aware, if you are having a vector A and you are having second vector B. These are two vectors and you are adding them. What will be the resultant vector? ठीक है? This will be the result by parallelogram method. This will be the resultant vector. ठीक है? R vector will be A plus B. What will be the, and this angle will be theta. Theta. So what will the magnitude of this R? That will be square root of A square plus B square plus 2AB cos theta. ठीक है? Now what will be the direction of this R vector? So for this purpose, I want to find out this angle, suppose alpha. This alpha is with respect to A. So tan alpha will be how much? Alpha is with respect to A. So choose another vector with respect to A. So choose B here. So it will start with B sine theta. Oh, sorry, this will be theta, beta. Please make it correct. This will be theta. Make it theta. So it will be tan alpha you want to find out. So this will be, this is with respect to A. So this will be B. This will be B sine theta divided by this will be A plus this will be B cos theta. This will be tan alpha. This will be.
So this slides once, please.
Yes, beta, please. I will show you all the slides. So please make it correct. This is theta. You are finding alpha. So wrongly I have written this. You are finding alpha, so it will be in terms of theta. This is the first one. This is second. So if you look here, for elastic collision, E will be equal to 1. Okay? E will be 1. And if you observe this equation, try to understand here, what is this equation? If you look here, this is V2, I bring this here. So this will become V2 minus V1. V2 minus V1. And this will be, if you look at, this will be U1 minus U2. So this is the equation where, what is this? This is velocity of recession. What is this? This is velocity of approach. And here, what is in multiplication with it? That is 1. So here, this coefficient of restitution E, it is 1 here in case of elastic collision. Beta. Okay? This is second slide. This is third one. This is third one. This is fourth. This is fourth. Fifth. Sixth. Sixth. 7. 8th. Nine. Ten. So these are all the slides. But in the next class, in 2 hours or more than 2 hour class, I will discuss all the numericals related up to this point.
Thank you, sir.
Welcome, beta.
Thank you, sir.
Welcome, beta. Good night.